Hi there, my name is Tyler Helble, and I will be sharing our work on fin whale singing behavior in Hawaiian waters with you. I'd like to acknowledge my co-authors, Regina Guazzo, Gabriella Alongi, Cameron Martin, Steve Martin, and Elizabeth Henderson. We are all part of the Whale Acoustics Reconnaissance Project, or WARP Lab, at the Niwik Navy facility in San Diego, California. Little is known about fin whales in Hawaiian waters, which leads to several motivating questions. We detect 20 Hz fin whale songs in the winter months with two note types, A and B. These notes occur at regular patterns of internote intervals. There's an ongoing discussion about the origin of these song patterns. For example, are the song patterns unique for different populations, or are the song patterns culturally transmitted between populations, similarly to humpback whales? There are also currently an unknown number of fin whales in Hawaiian waters, and so examining the song patterns will help towards establishing a Q rate that could eventually lead to PAM-based density estimation. The Pacific Missile Range Facility is a Navy testing and training location off the coast of Kauai, Hawaii. For this study, we used 14 hydrophones to acoustically detect, localize, and track fin whales as they pass through the range. The area monitored is highlighted, showing the approximate hydrophone locations and coverage area, which is 60 kilometers to the north-south and 20 kilometers to the east-west. The location uncertainty is on the order of about 50 meters when localizing the whales. Here you can see an example acoustically derived fin whale track as the track traverses the range over a 12-hour period from the north end of the range to the south end. The recording effort spanned the years from 2011 to 2017, which contained 115 whale tracks with 50,000 unique A and B notes. We were only able to analyze this unprecedented data set with the help of our automated infrastructure, which has been built over many years. Manual verification of our automated processes took place during the lockdown period of the pandemic, where Regina Guazzo and I spent the first month of quarantine in our homes manually verifying every one of the 50,000 notes in Raven Pro. The silver lining of this lockdown period was that we were able to achieve a much larger sample size than any previous fin whale song research. In this slide, let's examine the example fin whale track I showed earlier in more detail. As noted before, this track traverses from the north to south over a 12-hour period. The spectrogram below shows the two 20 Hz note types for 80 seconds of the track. We labeled the lower frequency, more narrow band notes as A notes, and the broader band note with a slightly higher peak frequency as the B note. Historically, these notes are sometimes referred to as the beat and backbeat notes, with the A note being the backbeat note and the B note being the beat. However, this nomenclature is a bit misleading because the notes can occur independently, and there are several instances where the A note or backbeat can occur without the beat or B note. Multipath can also be seen in the spectrogram, as highlighted here, but luckily the multipath signals were not categorized by our automated system because the detections on the multipath notes did not result in valid localizations. The note type and internote interval were logged for each note as well as the transition type. For example, A to A, B to A to B, and B to B. This annotation can be seen visually in the upper right-hand plot. This song is mostly A to B and B to A dominant with a fairly regular 12 and 20 second internote interval. However, not all fin whales were this consistent in their song patterns. Here you can see an example fin whale track that suddenly switched to a new song pattern, and this change happens within the song bout. This track is of a northbound whale tracked for over 6 hours. You can see an initial A to A doublet song with a 32 and 38 second internote interval transition suddenly into the AB 12-20 second internote interval that is described in the previous slide. In total, there were 45 tracks in our study that contained 2 or more song patterns with at least 20 note pairings of each pattern. With a single hydrophone, we might assume that this sudden transition to a new song pattern is indicative of another whale starting to sing. But with the high precision of our localization methods, these seem to be examples of individual whales singing multiple song patterns. If two whales were extremely close together, it may be feasible that the song could be produced by both whales, but this would require extreme coordination in both movement and song. Either way, these examples seem to dispel the hypothesis that different song patterns are indicative of different populations. There are 5 distinct song type pairings that can be seen from the years 2011 to 2017. Filled-in markers indicate a doublet pairing, while open markers indicate a singlet. The doublet pairings means that the internote interval has alternating lengths of time between the notes that are not the same. At least 20 instances of each note type pairing were required in order to be categorized and shown in this plot. Interestingly, the note pairings denoted with an asterisk had similar note types and INIs to those observed off the west coast of North America. However, the INIs are delayed in time from those seen on the west coast, so what's seen on the US West Coast is observed in Hawaii a few years later. One hypothesis is that the Hawaii fin whales seem to be somewhat separated from West Coast fin whales, and that they are likely not interacting regularly, or the INIs would be more in sync. It is possible that cultural transmission initiated by a few individuals is causing the song trend to reach Hawaii over time. A similar phenomenon was shown with humpback whales in the South Pacific in a 2011 paper by Garland et al. The INIs are also increasing in duration over time, which means a slowing down of the song. From 2011 to 2017, the AA singlet song lengthened the most by 1.3 seconds per year. Similar song lengthening has been observed on the US West Coast and also in other regions of the world, but it is unclear why the INIs are gradually increasing and whether they will continue to do so or perhaps reset or begin to decrease. Here we see the percentages of the note pairing types for each of the 115 fin whale tracks. In addition to the INIs gradually shifting over time, we also observed that the dominant note pairing changed over time. From the years of 2011 to 2014, the note pairings were AA dominant, but from 2014 to 17, the note pairings became AB dominant. Similar song pattern shifts were also reported off the US West Coast, but the shift from AA dominant song to AB dominant song happened earlier on the West Coast than observed in the Hawaii data. The along track Q rate of fin whales was calculated for the 115 tracks. The median Q rate was 131 notes per hour, but the median and variance shifted with the change in dominant note pairings. In order to calculate animal density from passive acoustics, we still need to know the percentages of whales that are in a vocally active state and the percentages of time that vocally active whales are singing. Research from this study suggests that counting notes might not be the best cue to use for density estimation, and perhaps counting the song bouts or the number of tracks would be a more consistent cue. However, this would be more difficult to achieve using single hydrophones. In conclusion, fin whale song patterns are more complex than previously reported in other regions, which are often characterized by a single song type. Our research has demonstrated that the internote interval and the note types are both important. We've also demonstrated that individual whales sang with multiple song patterns and switched between these song types even within a song bout. The dominant song also shifted over time. All of these changes affect the number of notes produced by the singers per hour, which further complicates passive acoustic monitoring-based density estimation. If you want to learn more, please see our recent publication in Frontiers, and also check out our shared data on OBIS CMAP. Also, stay tuned as Regina Guazzo will talk about the swimming kinematics for these same 115 fin whale tracks in this same section. Thank you.